All right, this is a pretty short talk about a theorem that we see in pre-calculus and then again in calculus. It makes a little bit more sense once we get to calculus. It's called the intermediate value theorem. So its statement formally says if f is continuous on closed AB, that means we include the endpoints, and we're going to claim that C is between f of A and f of B. Then there's some number t that lives inside the interval AB such that f of t is equal to c. So it's a little bit confusing. So a picture might help out here. And so here we have a and f of a and b and f of b. So if we wanted to plot the points, there's a f of a, there's b f of b. So what the intermediate value theorem says is that if there is some function that is going to connect these two dots continuously, so there's no gaps, no jumps, no discontinuities at all. So it might look like this. We don't know exactly what it looks like, but it might also look like this. So there's some function that passes through these 2 points. It says any number c that's between f of a and f of b is going to be reached pretty much. And it's going to be reached by a number that's between a and b. So there's c, somewhere between f of a and f of b. And we're saying that there is the number t that gives us c, and then we can keep going there and complete the function. And this happens because the intermediate value theorem is true. So any value between f of a and f of b, we're going to attain by some number between a and b. Another example, maybe a little bit further down. There we hit c by some number between a and b. So we mostly use this to find roots. This is where it's really useful. So let's say now that when we plug in a, we get a negative number, f of a. And when we plug in b, we get a positive number, f of b. So plugging in a gives a negative. Plugging in b is going to give us that positive there. So if we think about a continuous function, it's going to have to pass over the x-axis. In order to connect these two dots, the graph has to cross that x-axis. That's what the intermediate value theorem pretty much says. So if we just tried to draw it, at some point we have to pass through there. And since it's a function, we can't go way out past b to the right or past a to the left and then loop back around. It still has to pass the vertical line test. So there we have f of t is equal to 0. So one basic example here. Show the function has a root on 0, 4. And we're given f of x is equal to negative x cubed minus 2x squared plus x plus 4. So first we want to evaluate f at 0, the endpoint. When we do that, we get 4, that's positive. And we'll evaluate the other endpoint. It's negative. So by the intermediate value theorem, since one's positive, one's negative, there's going to be some number between those two values that gives us 0. So if we were to just look at the graph, so notice if we were at 0 and 4, that root might be somewhere around 3 there, where it passes through the x-axis. And there it is.